2.9 is for loops. There's a few assignments here. We'll take a quick look at the slides. Same as in Carol, we should know this. As we step through, different things happen. So, I starts at 0. We don't increase it yet. System out. I starts at 0, print 0. I++. At the end of the loop, I is still less than 3. We go into the code. I is now 1. Print 1. Increase it to 2. Still less than 3. Print 2. I is 3. False. Exit. That's it. That's how a for loop is. That's a basic code that we traced in class. Let's look at our lessons. Repeat 1,000 times. Repeat what? 1,000. Write a program that prints hello Carol exactly 1,000 times. Start a counter at 0. What are we printing? The statement in the assignment that we could just copy and paste. Don't forget it's a string. Needs to be in quotes. Looks like 1,000. We could also start this at 1. Make this went the wrong way in my head. This would also work because it's still 1,000 numbers because we include 1,000. But I like to start counting from 0 because strings start at 0. Another video on general for loops. We won't watch that, but you can watch that on your own. Here's a countdown example. We're counting down from 100 using a for loop. We can decrement with minus minus. We can increase plus 2 equals. We could do a lot of things. Boom. Countdown from 100. Second example is count by 2's. Plus equals 2, and then we print I. We're going to save this for loop for a second because, as I said, printing the odds in class, and Control-C, Control-V from the last example. That's the for loop from the last example. Indentation's a little off, but don't get too crazy about it. Instead of starting at 0, which is technically even, we start at 1, which is odd. What's the next odd? 3. 1 plus 2 equals 3. And that's all the odds. Are we supposed to include 101? Nope. We're good to go. Reusable code. Another video with some examples. Okay, these are constants if we declare static, final, and put the variable name in caps. It means that we can't change it later. We already really can't change variables that we're passing to a for loop if we do it in methods, which we get to later. So don't worry about that for now. We'll probably start using that when we get to Unit 4. This is example. This is a basic sum function. So we're going to start at 1, go to 1,000, and add all those numbers. Every time we go through the loop, it adds I. So I starts at 1. Sum starts at 0, so the first time through the loop, 0 plus 1 equals 1. Second time through the loop, 1 plus I equals 2, because we increased it by 1, it's 3. Next time it's 3, so the sum is now 3 from adding 1 plus 2. Now we add 3 to it, we get 6, and so on and so forth. Let's run it and see that. Okay, it's only going to show this. Let's look at how we can kind of bug test our code and see what happens. So we're going to write our I is, and then print the variable I. This will let us see what's going on in the code. And we're going to also print out the sum so we can see what's going on. This only prints out the final one, so it's kind of hard to see. And the final one, just to see everything. And I forgot quotes, but we know how to fix that, right? Throw on quotes. Okay. So now this code is going to declare some variable, print out, hey, we're starting at 0, and then the for loop will begin. We'll see the current value of I, which will start at 1. We'll see the current value of sum, which should start out at 0 that we first printed, then it's going to add 1 to it, so this will be 1. Next time through the loop, I will be 2, and so on. We're going to make this a little bit smaller, just so we can see it, because otherwise we'll start at probably 500. Okay, starting value for the sum is 0. Like we said, our I starts at 1. We add 1 to 0. We get 1. Now I is 2. We add 2 to 1. We get 3. Next through the loop, I is 3. We add 3 to our sum. We get 6. And so on and so forth. And then it prints out the final value at the end. If we change it back, we're only going to see the end, and we get our final answer. Just slowly adds bigger and bigger numbers. Same as a sigma function in math, if you were curious. And the final assignment, factorial, which we've seen 1,000,001 times. Factorial is when we add an exclamation point to a number. You might see it in probability, and then we multiply each different number down. So this is like if you have a certain number of choices. Let's say you had 10 shirts, you can wear one of them without replacement. It would be 10 factorial different orders you could pick from. So let's actually code that out. So use your input for the factorial you want to find. So we're going to make a starting number variable. Let's just copy and paste their prompt so we don't get it wrong. I'm going to make my code a little bit smaller. I know it might be hard to read, but we also need to be able to see the whole line. Okay, we're going to store whatever number we enter. In this case, they gave us 4. We don't want to do that ourselves. That's the user input. And now we're going to do the for loop that makes it. So first we need to start by making another variable. It should start at 1, because if we multiply 0, like I made a mistake on that little handout in class, we don't get a good answer. We would just get 0. And 4, start it. We're going to use I, of course, to do it, because it's like an iteration. That's kind of why we use I. I equals, we want to start at the starting num. Semicolon. I is greater than, we want to stop at 0. Multiplying 1 as our last answer. I guess we could stop at 1 because we don't need to add that last one, but you know, doesn't really matter too much. We're going to subtract from I. I should put spaces in until we get down to 1. Do you really need to multiply by 1 at the end? No. So you could stop and actually do it, but this saves us 1 time through the loop. Ever so slightly faster. So what do we multiply? We're going to multiply our current I by the factorial answer, or the other way around. Since we're assigning a value to a variable, we have to have it on the left hand side, and we're including the right hand side. So the new value is the current value times I, which we're counting down from our starting num on. The first time through the loop, I equals whatever the user enters. Then do we print it? Yes, we print it. We don't return yet. Let's check our code. If we enter 5, it's 5 times 4 is 20, times 3 is 60, times 2 is 120. Looks good. Let's see if we got the input right. We did. That's all for 2.9.